Okay, greetings class. This lecture is going to be on case 3.2, the Wiresharek, capturing a packet and then decoding that packet. The first thing we're going to do is we're going to open Wiresharek. Now you should have Wiresharek already from the first case project. If you don't, you just go to wiresharek.org and you download the Wiresharek client. I have it already. There's the download. I'm going to go ahead and pull up Wiresharek. So Wiresharek does open. It wants me to snap it over to the left side, so I just simply drag it over and snap it. On the right side, it wants me to open up a browser. So I'm going to go ahead and open up a browser, and I'm going to snap it over to the right. If you can't snap it, you could simply just split the windows. That's fine. As long as you're able to access Wiresharek and a browser. Step 2 wants us to go ahead and start a Wiresharek packet capture. For the interface, I want to make sure that wired is selected. I want to choose the correct interface. You'll see that traffic is on this one, but not on this one, this one, or this one. So the capture button won't illuminate until I'm on something. So let's say I'm not on anything. The capture start button is not illuminated. But if I was on one, and let's say it's the wrong interface, like local connection 3, which has no traffic, I can still start a packet capture, but I won't capture anything. So I want to make sure that I'm on the one that you could kind of see that there's some network traffic going on, not the ones that aren't, right? This is a desktop, so I don't have Wi-Fi connection, right? So we just want to make sure that we pick the right interface, and then we'll go ahead and start a capture. It wants us to go ahead and load Google. And once the page loads, it wants us to stop the packet capture. So that's all we had to do for step 2. Okay, class, for step 3, there's a little bit of confusion. It does ask you to apply a filter, and it does ask you to apply port 80 as a filter, and to also look for a DNS message that you are resolved to Google. So in this scenario, Google is HTTPS. So if you were going to HTTP, that's port 80. HTTPS is port 443, so you won't see that in there. You won't, if you filter for port 80, you won't see it. And I'll just go ahead and show you how to filter. It's simply right here. You just type in HTTP and select the HTTP and select the filter. And I've gotten 2 results, but both of those results do not lead to Google. So I'll go ahead and clear those results. What I do, and then the DNS, I actually don't have a DNS that resolved. What a DNS does is when you type in a name, it resolves the name to the IP. Sometimes when that's cached or known, it doesn't come up in your Wiresharek as well. So what I'm going to do in this case is I'm going to ping Google. I'm going to get an IP address, and I'm going to look for that IP address in my destination. And it could be numerous ones because, again, they don't have they have many IP addresses for particular sites. They don't have just one, and that's for failover purposes. So we are going to for 74. Or we could look for Google. So just to show you, HTTPS or HTTP2 filters to nothing, right? So just be careful of that in your assignment. We'll go ahead and find what we're looking for here. We are looking for Google and that TCP/IP connection. So going through the packet capture, I did find an MDNS, a master DNS for Google. You can see that the source is Google. So I'm able to find the Google conversation with the DNS that they're looking for. Again, what that does is it resolves the Google name to an actual IP address. So we're going to go ahead and find the IP address, which is 64 dot. So we're going to just sort by source IP, and here's our Google conversation. So we can go ahead and it's basically the transport layer of security version 1.2. Again, that protocol is the protocol for secure traffic on the web there. So we're going to go ahead and go to that 64 IP address, and then we'll go on to the next step. There we go. So here's our Google conversation. Okay, so I'm gonna go ahead and mark it. So I just right-click and mark the packet so we can analyze the packet a little bit more based on our requirements. So it wants us to analyze the OIU, right? We're on step 5 now. We've done pretty much the filter, the DNS, the finding the frame. So what we're going to do is we're going to try to analyze this packet. So it wants us to analyze the OIU of the source NIC, right? So we go to the source NIC and we find that it's Hewlett Packard, right? So that's my NIC is a Hewlett Packard, right? The destination NIC or network interface card is a Belkin. And for question B, it wants us to figure out what IP version was used. So we'll just minimize that. We'll go to IP version. It says we're using that version 4, right? We have a source of 192.168.1.158 and destination of 64.233.177.155. And just to give you a quick check on this, right? What if we wanted to just confirm that that packet is what we're doing, is the right packet? Because sometimes you know, there's confusion. It's not telling you which one. You're not sure if that's the right one. So we're going to do a ping-A. When you -A, it resolves the name to the IP. Right. So I guess that's part of the Google naming convention, right? The -A gives me a name to the packet. Question C is saying if the message used IPv4, what is the time to live? If IP6, what's the hop limit? So we used IP4. We should be looking for the TTL, the time to live. And in this case, it was 128. Right, so that would be our answer for that one, part C. The very next question is the same analysis is right underneath it. It's asking, did the message use TCP or UDP? And in this case, it did use TCP, right? It's right there in that Internet Protocol, right? We were able to see that it did use TCP. It wants to know what is the source port and destination. So we're going to go to the TCP, the Transmission Control Protocol. So we'll go ahead and minimize that. We'll open this up, and it wants to know the source port, which is 54008. The destination port is 443, right? That is HTTPS. That's the port for 443. And generally, when you're going outbound from your computer, the source port is generally high. The computer just uses a port that's free, and the destination port is based on a specific protocol, like HTTPS in this case. When you start receiving destination ports of higher, right, coming inbound, like let's say we're getting a 54088 inbound, then that could be an indication that there is a virus. So you want to keep your eyes out for that, right? So Wiresharek is used to troubleshoot network. In this case, we're actually able to read a packet. We did answer all those questions in step 5, and now we're going to move on to step 6. Okay, step 6 wants us to filter and use a SYN, find the first SYN message after DNS request, and then open the header in a second pane to answer the following questions. So it then gives a warning about if you can find a TCP stream, the web page requested your system may be in port 443 and not 80, right? So we know that we are in port 443. So go ahead and filter your Wiresharek by pressing the info and find a SYN request and open up that SYN request, right? I can see right here the SYN. So we're going to go ahead and find any SYN request and open it up. And the question is asking what is the sequence number and the flag. So if we open up our transmission control protocol, you'll see a sequence number, and then further down you'll see a flag. So you would find that information here. And when you're going through these questions, make sure you click on them so that you could actually see the numbers, right? I just moved it there, but when I click on that sequence number, it's pulling the sequence number from the bottom pane. Same thing with flag. You want to go ahead and click on it to show your answer there, right? Make sure you don't highlight in there, because then you can possibly change it. So you're just going to click on there, sequence number. Let me go ahead and click out and click back. Okay. Okay, step 8 wants us to change this hexadecimal form into decimal form. What we need to do here is we're going to click on Edit. We're going to go down to Preferences. We're going to go to Protocols. We're going to find the TCP protocol. I just typed T there so it came up easier, and we're going to uncheck this relative sequence numbers. Okay. Now what we're going to do is we're going to just open up another packet by double clicking it. We're going to look at that TCP. We're going to look at that sequence number again, and we're going to see that the number has changed to decimal instead of that hexadecimal, right? And now it wants you to compare the numbers that we just found, the relative sequence numbers to figure 3-28. We're going to go on to step 9, where it wants us to click on one of these packets. We'll right click it. We are going to follow the TCP conversation. So we're going to go to follow, or the TCP stream, and we're going to click follow that TCP stream. Now we're going to close that follow the TCP stream. We're going to go on to the next step, step 10. So what it's saying here, step 10 is immediately after that SYN message that we're tracking, go to the SYN acknowledge message. Make sure that you're in number sequence. It could be all jabbled and you don't know where you are, and so you want to be in number sequence here, right? And although it goes from 92 to 246, this right here, we're following this conversation. So I was able to find the SYN and the SYN acknowledge, and we're going to answer some questions about it. Question 1 is, what is the source IP? And that's right there, source IP. What is the destination IP, which is right here? What is the sequence number? So we know if we can go and click, we can find our sequence number in the IP protocol, or actually TCP, right? If we're using TCP value, right, we're using the source IP, source destination, again, source destination. We're going to find that sequence number, right, in the transmission control protocol. And these are all similar to what we just did before, right? The finding the flags. Okay, so this is all similar. So you're going to go on and answer question 10, which is the flags, the segment, and the TCP IP. We're going to move on to question 11. Question 11 is asking us to find that acknowledgement statement after the SYN and ACK, right? Acknowledge here. We're going to answer the questions about similar, right? Source IP, destination IP, flags, sequence numbers, the same thing we just did, right? So you're doing the same exact thing. Well, question 10 and 11, you're just finding the next packet. And then finally, question 12 is just referring to the actual handshake conversation that takes place. So we found the SYN ACK, the ACK after, and now the server exchange with the handshake message, right? It's asking for source and destination IP, which you already know. It's asking for the flags, which you already know how to get to, right? We've done that in several of the transmission control protocol flags, right? So now it's asking about the type of packet, right? So we know it's a secure socket layer packet. And the types of headers, right? They're encrypted headers for the secure socket layer. You can just go here and see that TLS 1.2 is a header. So it's just asking you about the different types of encryption level and what you're getting, right? So you're just going to go here, right? The length is 40. It's a handshake protocol. It's an encrypted handshake message. So that's pretty much it, folks. Good luck with your packet capture.